So we're going to begin in Chapter 1, which is kind of a foundation for the semester. So Chapter 1 is going to be introducing what statistics is and some statistical terminology. And we're going to look at some different types of data. We're not going to spend a whole lot of time in Chapter 1. We're going to probably finish this chapter up pretty much maybe a couple videos or so. So I want to start off, what is statistics? Statistics. So you hear about statistics. So if you're into sports, probably you've looked at, if you're into baseball, right? You have a baseball player who bats. You hear things like RBIs, that's the number of runs batted in, right? You hear about number of home runs. You hear about, what else? If you're a pitcher, you hear about ERA, right? ERA, that's a number that tells you pitcher success. So, so statistics is basically, it's about information. It's about studying data. So statistics is the scientific study of data. The branch of science concerned with data. Concerned with the study of data. So you hear that word data. Data is just information, basically. Data. Information. That's collected. So we'll say collected information. So when you got some raw data collected, it's not very useful. So what you often want to do, you want to organize your data and analyze your data and make it useful. So there are two branches of statistics. One is called descriptive. Let me write two branches of statistics. Two branches. Of statistics. Statistics. So the first one we're going to call descriptive. Statistics. So that branch of statistics is concerned with collecting data and describing data. Involves collecting not working this pen and describing. I got this iPad mini here with this big old giant stylus. Kind of hard to do. Involves collecting and describing data. So collecting data is a really big deal. We're not going to spend really time with that much. Yeah, it's a really big deal, collecting data. How you collect your data is really important. We're going to spend some time, though, analyzing our data and describing our data using different presentation methods. That's mainly what we're going to be doing in descriptive statistics. Taking data that we assumed has been collected, and we're going to analyze it, summarize it, describe it. All right, so the other branch of statistics is called inferential. Inferential, it's an R there. that involves making predictions or inferences, making inferences or predictions, you might say, about uncollected data. Uncollected data. Pen's not working, hardly. Not sure what's going on. All right, so a lot of times when you have a large group of things that you're interested in studying, you don't want to go out there and you don't want to collect all the data on that group. A lot of times what you want to do, you want to look at a specific subgroup. Look at a subgroup, which we often call a sample, and we'll gather data on the sample, and then try to make predictions or inferences about the entire population. So we're introducing two words here. Population and sample. So what is a population? It's an entire collection or an entire group. Let's use the word group. An entire group of things or objects we are interested in studying. We are interested in studying. So remember, population is an entire group. A lot of times, though, you're not going to collect all the data for an entire population. Sometimes it's just too time-consuming. Costs a lot of money, too, to collect that much data. A lot of time, a lot of money. So oftentimes we look at what's called a sample. A sample is a subgroup. A subgroup of a population. And oftentimes the way we pick a sample, we pick it randomly. What does that mean? What does it mean to pick a sample randomly? It means we just kind of pick one here and pick one there. It has to be an equal chance that we're picking a sample. Every individual in the sample that gets picked, it's an equal chance that they get picked. All right? So a sample is a subgroup of a population. Couple more terms I want to throw out. I want to throw out the words parameter and statistic. Parameter and statistic. So what is a parameter? So parameter is a numerical measurement for a population. A numerical measurement. An A back there for a population. So some common parameters that show up a lot are proportion, or sometimes called percent. So what percent of people have brown eyes, for example? So that's proportion. So we use the lowercase p. That's a lowercase p right there for proportion. Another parameter that's pretty common for a population is the mean, also called the average. So the mean or the average, that kind of measures where the center of the data for a population is. And we use this strange letter. This is a lowercase mu. It's a Greek letter mu. It looks like a funky M. Let me write that one more time to show you how it's written. Like that. Yeah. Oh, strange. That's a Greek letter, lowercase Greek letter. In math, they use a lot of Greek letters. In statistics, they use a lot of Greek letters. Another big one. We'll see later down the road. Variance. So variance is a quantitative measurement, a numerical measurement that tells you how spread out your data is. So the bigger the number, the more spread out, and the smaller the number, the closer together your data is going to be, numerically speaking. So they use this letter, Greek letter, sigma. This is lowercase sigma, and they put a little square over it. It's not writing very well, this pen. Sigma squared. There we go. So sigma with a 2, a superscript 2. That's the variance. Another one you see a lot is standard deviation. Standard deviation is just another measurement that tells you how spread out things are. The standard deviation we call sigma, and it's basically the square root of the variance. Square root of the variance. You just take the square root of the variance to get the standard deviation. It's telling you almost the same thing as the variance. It's telling you how spread out the data is numerically. Bigger the number, the more spread out. The smaller the number, the less spread out. All right. So these are all parameters that are common. Proportion, which is like a percent. Mean, which is average. Variance and standard deviation. These are measurements of how spread out the data are. Now remember, parameters apply to populations. So analogously, we have something that applies to samples. And we call these things called statistics. So a statistic singular, it's a numerical measurement for a sample. A numerical measurement. For a sample. So remember, parameter goes with population, statistic goes with sample. I mean, that makes sense, right? Parameter, P, population, statistic, sample, right? The P goes with the P and the S goes with the S, right? So, I mean, you got the same exact numerical measurements for samples as you do for populations. You have proportion, which measures the percent of something occurring. You got the mean, which is the average. You got the variance, which is how spread out data is. And you got standard deviation, which is how spread out data is. The thing is, you got to be mindful to use different symbols when you're dealing with samples. So when you're dealing with samples, when you're talking about sample proportion, you're going to use P with like a hat symbol over top of it. So P with a hat, that means sample proportion. So the statistic would be sample proportion when you see that hat. Anytime you see X with a bar over top of it, that means mean of a sample, or sample mean. So be aware of that difference. When you see this symbol, lowercase, that's a lowercase s with the square symbol over top of it. That's my square right there. S squared, that's the sample variance, not population variance, right? Population variance is at sigma squared, but S squared is sample variance. And finally, sample standard deviation is simply S, right? It's going to be the square root of the variance, S squared. So sample standard deviation is lowercase s, and it's the square root of the sample variance, S squared. All right, so be aware of those differences in notations. Population parameters have certain letters, and sample statistics have certain letters that are different than the population parameter letters. Why is this not going up? Okay, I don't know, it's not going up. All right, let's do a few examples. We'll do a couple examples. How about we do example 1, 50. Male college football players are randomly selected. And their weights are measured. Guess they get on scales, right? Some kind of scale. Their weights. Ooh, that didn't turn out well, did it? Try that one more time. Their weights are measured. Okay. The average weight, their average weight, is 198 pounds. We're going to have some questions about this scenario. Part A. Tell me, what is the population? Part B, what is the sample? So determine the population. Part B, let's figure out what the sample is. Determine the sample. In this scenario. And part C, what is the statistic here? Determine the statistic. Statistic. Oops, didn't want that. All right, so I think the easiest thing to find out is what is the sample? Remember what a sample is? It is a subgroup from a population. Oftentimes, rather than taking all the data from an entire population, you just want to take the data from a sample. Sample is usually randomly selected. That's great when it's randomly selected, so it's representative of the population. So what's our sample? So it looks like we got 50 male college football players are randomly selected, and their weights are measured, and their average weight is 108 pounds. So here we're taking a sample of 50 male college football players. So 50 male college football players. Yep, that's your sample. It's the subgroup of things that are randomly selected. Now, population. Remember, population is the entire group of all things that you're actually interested in. So what would the entire group of all things that we're interested in be? It would be all male college football players. So male college football players. So all male college football players. So in this situation, we're only taking 50, which is a sample, to gather data on. But in actuality, we're interested in probably finding out about all college football players. All male college football players. All right, so statistic. What is a statistic? Remember, a statistic is a number, a quantity a quantity having to do with the sample. So notice here, we have their average. That's the sample's average, right? The sample average. That's the mean, right? So mean. The statistic here is the mean. So the key word here is average, right? Now, what letter do we use for the mean or the average when you're dealing with the sample? You use this one right here, right? X bar. X bar is the letter we use. I put X and I put a bar over top of it, equals 198, right? There we go. Our statistic here is the mean. Sample mean, actually. Sample mean. I'll just call it mean. X bar equals 198. So it's understood to be the sample mean when you put the bar over it like that. All right, so let's do a number 2. Situation. A number 2 situation has to do with people with respiratory symptoms. 40 patients with respiratory symptoms. Respiratory. Oh, it's not going to write, is it? Let me go to the next one. Hardly any room. So what's respiratory symptoms? That means like coughing, sneezing, difficulty breathing, runny nose, that kind of stuff. 40 patients with respiratory symptoms are randomly tested. Randomly selected. So we're selecting these 40 people from a group of respiratory symptom patients. We're randomly selecting only 40 patients from a larger group of respiratory symptom patients. So 40 patients with respiratory symptoms are randomly selected and tested for COVID-19, the virus. For COVID-19. Period. The testers then determine that 15% of these patients test positive. All right, so that's our situation. Part A, what's the population? Part B, what's the sample? Determine the population. B, determine the sample. And part C, how about let's figure out what is the statistic, singular here. Determine the statistic. All right, I think the easiest thing to find here is the sample. What is the sample? So we're taking randomly selecting. So anytime you hear the word randomly selecting, that's going to be your sample. So we're randomly selecting what? A subgroup of 40 patients with respiratory symptoms. The randomly selected let me say the 40 patients. The 40 respiratory patients that are randomly selected. The 40 respiratory patients that are randomly selected. That's a good way to put it. So if this is our sample, this is a subgroup of an entire population. What is entire population? Well, that would be all respiratory patients, right? All respiratory patients. So anyone who has respiratory symptoms. And that would be a patient. So all, oops. Patients with all respiratory patients. All right. Okay, so the statistic. Well, the statistic is a numerical measurement that gives you some information about the sample. So what's statistics? So the testers then determine that 15% of these patients test positive. So what is this 15% here? That is a proportion, right? Anytime you're talking about percentage, you're dealing with proportion. All right, so what letter is for proportion? Anybody remember? It involves a P, but it has a little more than a P. P hat, right? P with a hat is sample proportion. Now, if you're talking about population proportion, you just put a P, but we're talking about just a sample of 40 individuals here. So we're going to use P hat. So I'm going to write P hat. And all right, equals 15%. Or if you want to, you can convert that to a decimal. All right, or you can write P hat equals 0.15, right? How do you convert that to a decimal? You just move the percentage sign 2 to the left and make it a decimal. All right, take the percentage sign, move it 2 to the left, and turn it into a decimal. And that's how you get a decimal version of your percentage. So 0.15 or 15%. All right, I think we're going to stop there. Probably our next video will look at different types of data.